Yeah, good morning all. Myself Y. Himat Kumar, Assistant Professor, Department of Civil Engineering. So today our topic is about design of composite precast pre-stressed components. So designing composite precast pre-stressed components involves creating structures that combine the benefits of precast concrete and pre-stressed concrete. These components are commonly used in construction to achieve a high level of strength, durability and efficiency. So next now we are going an overview of the design process for composite precast pre-stressed components. So what are the project requirements and constraints are: understand the specific project requirements including load bearing capacity, span, aesthetic considerations and environmental conditions. Identify any constraints such as budget, timeline and the local building codes. So next one is about the material selection. Choose appropriate materials for the composite component. Typically this includes precast concrete and pre-stressing tendons such as steel cables. Considering the type of concrete mix, reinforcing materials and coatings for durability and aesthetics. Next one is about the structural analysis. So perform structural analysis to determine the loads and forces the component will experience during its service life. Calculate the required pre-stressing force to counteract external loads and ensure structural stability. And coming for the next one is the design concepts. Develop design concepts that integrate precast and pre-stressed elements, considering the configuration of the component, the arrangement of the pre-stressing tendons and the connection details. And next one is the detailed design. So create detailed drawings and specifications for the precast component including cross-section dimensions and reinforcement details, specifying the pre-stressing tendon layouts and the anchorages. Next one is the mold and formwork design. Design the mold and formwork requires for casting the precast component. Ensure that mold design allows for easy demolding and maintains the desired surface finish. Next one is the fabrication and casting. Fabricate the precast concrete component in a controlled environment such as precast concrete manufacturing facility and ensure that the precasting tendons are properly tensioned and anchored. Next one is the transportation and installation. Plan the transportation of precast components to the construction site, ensuring that lifting and handling equipments is in place for safe installation. Next one is the connection details. Design the connection details to join the precast component with other structural elements such as beams, columns or slab. Use appropriate connectors and methods to ensure the structural integrity. Next one is the quality control and testing. Implement a quality control program to inspect the precast components for conformity to design and specifications. Conduct non-destructive testing such as ultrasonic or visual inspection to ensure the quality. Next one is the maintenance considerations. Consider long-term maintenance requirements such as protection from corrosion, surface finishes, etc. Next one is the documentation as well as built records. Maintain detailed documentation of the design, fabrication and installation process. Create as built records to document the final state of the composite precast pre-stressed component. Next one is the safety and environmental considerations. Ensure that design and fabrication process adhere to safety standards and environmental regulations. Next one is the collaboration and coordination. Collaborate with the architects, structural engineers, contracts and other stakeholders throughout the design and the construction phases. And next one is the continuous monitoring. Implementing a monitoring and maintenance plan to ensure the long-term performance and durability of the composite precast pre-stressed components. Designing composite precast pre-stressed components is a complex process that requires careful planning, collaboration and attention to detail to create structures that meet safety, durability and performance requirements. It's essential to stay updated on the latest industry standards and innovations in materials and construction techniques to optimize the design and construction process. So coming for what are the instructional objectives for this topic is define composite precast pre-stressed components. So in this, students should be able to define and explain the concept of composite precast pre-stressed components, including the materials used and their advantages, and they will be understanding about the load analysis. Students should understand how to analyze the loads and forces acting on the composite precast pre-stressed component, determine the required pre-stressing force, and explanation about the material selection. To describe the process of selecting appropriate materials for composite precast components, considering factors like concrete mix, reinforcing materials, as well as the coatings. Next is about the design composite components, mold and formwork design, pre-stressing tendon layout, transportation and installation. And coming for the next one is the so we have to ensure that we will be having the structural efficiency, cost effectiveness, speed of construction, sustainability, flexibility in design, safety and reliability, durability, concrete controls. Okay, with this I am ending the session. Thank you.